Welcome in this room. This is very impressive to be here as a speaker with such an introduction. I did film school a long time ago. This is the closest I got to ever being on a cinema screen, so it's fun to be here. I have a history lesson for you about changes in Java, pretty technical, about the FFM API, the foreign function and memory API, and I promise you at the end we also have some code or in between, and we'll have some fun with a Raspberry Pi, because what can potentially go wrong during a talk. But first a question for you. Who is already on Java 25, released 2 weeks ago? I only see a few hands. I don't dare to ask in production even. Whoever cloned the sources of OpenJDK? A bit more. That's really a fun thing to do. I'll tell you more about it. And who is following OpenJDK projects? Because these are the driving forces of changes in Java. Yeah. I'm going to tell you about one specific project in this talk. And then more importantly, who knows the JEPs, the changes introduced within each release? Okay, I hope I can inspire some of you to go check them out and read them a bit. My personal story of Java started right in the middle. 15 years ago, I started doing Java when I changed jobs and went from C# to Java and never looked back. It's actually funny because that's right in the middle of the Java history. So I will tell you in this talk about OpenJDK evolutions, how I went through this journey of using Java and following the releases, about projects and JEPs. Project Panama, that's a project we will take a look at. And then the JEPs related to that project, which brought us the FFM API. And how this has impacted the project. One of my pet projects is Java on the Raspberry Pi. How we can now do things better to control the GPIO's electronic components connected to a Raspberry Pi. Because we have this project, the Pi4J project. By the way, if you're a fan or user of Pi4J, I have stickers. We have our first merchandise. The Pi4J project is a Java library, so it's something you know. You use a lot of dependency. It's a dependency like many others. But this library relies on native code to talk to the devices connected to a Raspberry Pi on those 40 pins you see on the top of the Raspberry Pi. So we use a lot of C++ code, existing code, to call it, to instruct it to toggle a LED or read the state of a button. And thanks to the FFM API, we can take a big step forward with the Pi4J project. I often get the question, why Java on a Raspberry Pi? Why did I start doing that? Because Java is the language which allows me to do everything. I can build user interfaces with JavaFX. I can talk to other services with API calls and all the amazing libraries which are available. So Java is for me the best tool, is the tool I knew when I started doing Java on Raspberry Pi. So I didn't want to learn a new language. I wanted to know how can I use this language to do something else, which is interacting with electronic components. And we should thank OpenJDK, the Java project, for a lot of amazing stuff. The garbage collector. We don't need to care about memory, handling memory, which is a bit strange to tell you in this talk because we're going to play with memory. But actually, as an average Java developer, we don't need to care about cleaning up our memory. Just-in-time compilation. You can write code on any platform and run it on another one. And the Java runtime will take care of the native code conversion, and that we have the most optimal code. And then there were so many evolutions in Java, like the Stream API, the virtual threads, and now this FFM API. So there's so much ongoing in that OpenJDK project, which is amazing and offers us a lot of developer tools and friendliness. And what is this foreign function and memory API? 3 goals. Memory safety. Although we are stepping away from the safe garbage collector, we're going to play with the memory. So we want to have something which can safely be used to access off-heap memory and still have a nice cleanup. that we can interact with native libraries in an easy way, but also high performant. Java is a high performant language used in big cloud environments, so we want to keep that high performance also if you interact with other code. Maybe a few of you are here because of the interaction of Java with AI tools, with the foreign function memory API. So that's also their high performance, being able to exchange memory segments and call specific native code. Why am I telling you this story? So I'm Frank Del Porto. You can find me on all social media except the evil one with this hashtag. I have a GitHub account with another tag because, yeah, that was before I did marketing for myself. So I have 2 different accounts. And I love to use, write, and talk about Java and JavaFX. You can find my blog post on fujay.io, the website for the Friends of OpenJDK. Who's there on Fujay? 2 less hands, fujay.io. Never forget that website address. And I'm a technical writer at Azul, so I also write blog posts there. And I do the documentation for the Py4J project. Since 3 years, I work for Azul, which happens to be one of the few OpenJDK builders which has several builds of OpenJDK which run on a Raspberry Pi. All the links of this presentation, I will show you a lot, are on my website. So if you go to the post I published yesterday, you can find all the links there, so you don't need to write them all down. A disclaimer, I didn't contribute to the FFM project. I'm just a very curious person and try to and love to experiment. And my experiments with Java on the Raspberry Pi started 5 years ago. If you watched one of my previous talks or were here 2 years ago, 3 years ago, you've seen this movie. 5 years ago, I wanted to create a JavaFX touch-based interface on a Raspberry Pi for the drum boot of my son. So, of course, it's a pet project. It's way too complicated. But it allows us to call our son if dinner is ready. So there's an API inside. But it needed a way to interact with this relais and have a way to control an Arduino board. By the way, that little boy, so I said it's 5 years ago, it's now a teenager, and parents with teenagers knows what that means. My story of doing these experiments ended up in a book. The left one is sold out, but I keep maintaining the right one, the ebook. And last week I published a new version which contains Java 25, because 5 years ago I was using Java 11. So yeah, there has been quite some changes in between. And in the ebook will also be fully updated in the next months with the FFM implementation of Py4J. So as I said, 30 years of Java. What happened in those 30 years? A lot. I had a chat with James Gosling, the creator of Java, for the Fujay podcast. If you want to know about his original ideas and how he feels about some things which happened in those 30 years, it's a really great talk I had with him. We planned to do it for an hour and we went way over it. So he has a lot to share. Now, if you zoom in since Java 8, that's actually when some things started going faster. We have this 6-month release cycle. We have the LTS releases. I know a few of the other talks discuss if we still have LTS or not. The thing you have to remember here, every release is a good one. Every 6 months you get a new release of Java with improvements. If you're able to update your system, definitely your developer system, but also your production system, every 6 months you get improvements. The FFM API that I'm talking about now was introduced in Java 22. Yesterday I learned from someone, it is in a presentation this afternoon, that with Java 24, although there were no changes in the APIs, the performance went way up. So they're still doing improvements in existing code inside the Java runtime. So please try to keep a track of all these changes and go with the flow with all the new releases. So as I said at the beginning, I hope you check out the code. So OpenJDK, which is both the language and the runtime, is inside this JDK repository. So that means that you can get everything which runs on your machine as source code. And if you look into the tags, you see that they are already working on the 18th build of Java 26, which will be released in the beginning of next year. So you could already be working with Java 26 if you want. And that's what I've done. So you can, like for instance, these commands is everything you need to build OpenJDK, the runtime, on a Raspberry Pi. So you need to install some tools, start the command, and then wait an hour. That was some years ago. But at that time, Java 15 was released, but I was running, where is it? Somewhere here. 16 something, 16 internal. I was running 16 internal on a Raspberry Pi, so a not released version yet. So you can get this from the sources and build it yourself. What's also inside OpenJDK is the one thing a developer doesn't want to deal with, dates and times, and time zones, and daylight savings, and currencies. There is a whole database inside the OpenJDK project. I have this blog. Last year we traveled to Kazakhstan. We almost missed the plane when we went back home because they changed time zones that year. And I should have known because I write the release notes of Java for the Azul website, and I missed it. So I should have known it because it was part of the release notes of Java that the time zone change was there. But now we come to the project. So how does Java evolve? How are big changes introduced in Java is through projects. And if you go to the OpenJDK website, which has this very fancy layout, retro style, you have all these projects here. So these are ongoing changes within OpenJDK, and we will be looking at the project Panama. If you want to follow one of those projects, there are mailing lists, so you can see what people are discussing. How are we going to do this? What should we do? What should be in there? And there you can follow the whole discussion. And once a project becomes mature, it gets broken down into JEPs. And JEP is a JDK enhancement proposal. How are we going to improve the JDK? And that's one specific task that they want to introduce in a specific version of Java. And you see, again, there are a lot of those. So this is separate from bug fixes and small improvements. It's really a change within OpenJDK. So all the JEPs are here. I'm going to explain to you more. Oops. And there's also one thing you need to remember about the JEPs. They can be introduced in a release, in an incubator or a preview state. That means they are not finalized. They are stable, they are tested, you can use them, but it's not finalized yet. They are still maybe waiting for something else to be implemented in Java so they can finish it, or they want feedback from you. So all you here are invited to try incubator and preview JEPs and give feedback to the creators of those. And you can use them like in IntelliJ. There is, if drop down, which language features you want to use. There you have the experimental option. And if you do it from the command line, you have this enable preview that you need to add. So all this is possible. Okay. Project Panama. The project, the main subject of this talk, is a project which started in about 2014, and they had an idea of how can we improve and enrich the connections between the Java virtual machine and well-defined but foreign non-Java APIs, including many interfaces commonly used by C programmers. So how can we call C code and exchange data through the memory? How can we do that? That's the goal of Project Panama. I showed you the projects page. And to understand what they want to achieve is actually we need to learn what happened in history. So there are 4 ways you can do this at this moment. GNI, I'm going to mess this up a lot, I think. GNI is the first one. It's original. It was in Java 1.1, already a long time ago. So that's when the first request came. Yeah, we need a way to be able to talk from Java to C code. How can we do that? GNI was the answer to that. Then there were 2 libraries, and now we have FFM. So if you compare them, GNAI is the original one. It's a manual memory management with a steep learning curve. And actually, when I talked about this with my colleague Simon Ritter, who has a very long history with Java, he has this quote. I can't remember who it was, but I was talking to one of the engineers back at Sun and expressing my frustration with JNI being hard to use. That's when he said it has been developed that way to encourage people not to use it. So it's there, but please don't use it. Of course, except if you have a specific use case for this kind of functionality like we have here on the Raspberry Pi, we need a way to be able to talk to C code to interact with the GPIOs. But it's hard to use, it's very efficient, but it's complicated as a developer to use. So JNA was a first attempt to improve that. It's a library, which means it brings some overhead, but it's easier. Okay, that was a step forward. There was a second library being created, JNR, with runtime code generation. I don't like that much runtime generated code. So it's a solution again, it's efficient, but it's not the best solution. So they wanted to solve this main problem, which was already there for a long time with the FFM API. So it's part of the core, it's not a dependency. It has a very good memory management, high performing, can call methods in a library, and it has a very good approach of how you combine all this. A table, remember the right column, because that's the way forward. It's there in Java 22, it's part of the OpenJDK, no dependencies needed, so it means it's completely integrated in the runtime. It's easier to use, and the performance is at least as good as GNI, which was the main goal from the beginning. And how they achieve this, if we come back to the project Panama and the JEPs, is that they have broken this into separate blocks, and they got introduced one by one. So first they started with a foreign memory access API with 3 JEPs. So these JEPs, the goal was to allow Java programs to safely and efficiently access foreign memory and remove the use of byte buffer and the Sun MISC unsafe. Again, not to use it, unsafe. I think these are red flags if you have this in your code. We should not be doing this. And they had 3 JEPs to achieve that goal. And you see, none of these got finalized. Those were incubator features. So they were added to OpenJDK, but they were not finalized yet because they were preparations for something bigger. And you can go through these JEPs, and that's actually the fun thing to do if you're a bit interested in how Java is evolving. This is real. It can be boring too, but some of these are really deep insights of the architects of Java and people involved in how are we going to evolve Java. So they are thinking here about safety, about control, about usability. They describe with examples how they want to achieve this, which are the new APIs which will become available thanks to this JEP. So it's really a history book of how Java is evolving and how decisions were made and why they already did the research. They started Project Panama with a lot of research and then ended up delivering these JEPs. The same thing happened with the foreign linker API. The linker API is an API that offers statically typed pure Java access to native code. So how are we going to call an external library? That's where this linker API comes into the play. With one JEP. They solved it in one go, in one release. So it was in release 16, you had the implementation of the linker API. And then we come to the final full package, the FFM API. And they needed 6 JEPs to finalize it, to get feedback from the community. Do we do this the right way? Is this what you need to achieve your goal and improve your coding with this kind of use cases where you need to call memory and foreign functions? So the combination is this API to interoperate with code and data outside of the Java runtime. enabling you to call native libraries without the brittleness and danger of JNI. I like the wording they use, by the way, in the JEPs too. That's why I say some of these are really a nice story to read. And then you see this evolution within these JEPs. So they have 6 releases that they included this FFM API. First as an incubator, that means that it's really deep inside, touching the internals of the GVM. Then preview features, making it available to be used. And then at the end, it was finalized. So that means that in OpenJDK 22, this was delivered as a new feature that you can use in development and at runtime. All the JEPs, if you want to read them, be my guest. I have added all the links again on my website. And again, here you see it's about integrity, productivity, performance, broad platform support. So the things we know from Java, I said it before, Java is boring. The Java tomorrow will be able to run the Java applications you've written yesterday. That's what we want. We want boring stability. New features are fun, but we still want to have our existing applications run as we are expecting them to run. And that's what they bring with each of these releases. One thing you need in your Java code to use this FFM API to call native libraries is your Java application has to know which methods are available in your library. If you are using a difficult, complex, big native library, this JExtract tool can be used to get a Java file which describes all these methods. It's not part of OpenJDK. So if you install the JDK on your machine, you will not have this JExtract tool. They didn't want to make the JDK bigger for everyone because this will not be used by many developers. It's great functionality, it works very great, but it's not for everyone. So they didn't include it in OpenJDK. But you can find it, as this is all open source, of course, with a clear guide on how to use it on GitHub. Hello. Can I have an applause for the photographer of this event, because he always creates these amazing pictures. For completeness, I have to mention that the Vector API is also part of Project Panama. People who are looking into AI and using AI in Java development, also in vector databases, will be interested in this. The Vector API, you see, we already have a lot of JEPs, and I have a lot of question marks at the end, because we don't know when it will be delivered. They are waiting for another project, I lost the name, sorry, where there will be some changes in how you can define variables and use variables, I think. So you see, it's actually finished because there are some vector-based databases already using this because they just enable this flag use experimental features. So it's stable, it's good, but they cannot finish it because they're waiting for something else. So I have also in the podcast, every 6 months I make a podcast about the changes in OpenJDK, and each time, it's together with Simon Ritter, each time he says, yeah, maybe in 6 months it will be finalized. But yeah, again, it was maybe in Java 26. We'll see. We don't know yet. So the Vector API, it's not what I need here for the Raspberry Pi project, the Pi4J project. So it's a way to express vector computations on supported architectures. Intensive tasks like mathematical calculations, data processing, and machine learning workloads. So the buzzword of this conference and these times, the machine learning and AI, will probably profit from this Vector API. One JEP and many more. Please dive into the details if you want to learn more about it. I have a few very simple examples to show what this FFM API now brings for us as a developer. By the way, I'm using here for this demo Java 25. Another change introduced in Java 25, which also needed 3 JEPs to get finalized, is the simplified main method. So this is my main method. So for starters and people seeing Java for the first time, the private static final main string array args thing is gone. So you don't really need it anymore if you don't make use of it. I don't even have a package. I don't even have a class. I can just execute this code as is. So what this now does is a demo of how you can call memory directly. So outside of the garbage collector. So that means that every Java object is checked by the garbage collector from time to time. Is it still needed? And if it's not needed anymore, it's thrown away. But this brings some overhead. So this memory segment here that we get at this moment is outside of the garbage collector. So we have this arena. The arena exists during the lifetime of my application, and this is what will manage the cleanup of this segment if we don't need it anymore. So that's why it's in this try block. So we get here a memory segment. I just have a stupid loop 5 times, and I write, so we, oops, here. So the segment is a block which can contain 5 integer values, and I just put in some random values, and I read them back. So I don't need to tell you that this is not rocket science. For a stupid reason, this doesn't want to autocomplete. That's all it does. So, but it's a demo of that you can write directly into memory and read it back. If I want to do this with Java 11, I asked my colleague, Claude AI, to make me an example based on Java 11 to do the same thing. And it came up with this 3 examples. The byte buffer is probably something you all have been using somewhere to store a big chunk of data. The unsafe, which we should use because it's unsafe. And then something complexer with a JNI, but it cannot write the code because I first need to create a C library, compile it, then compile it with JNA, then call it with JNI, and no, we're not going to do that. By the way, also this code is part of the block if you want to dive into it. I have another nicer example of the memory use. I have this, let me just run it, that will be easier. Although I love JavaFX, this is done with Swing. I have here somewhere a thread, a schedule, and I ask my application to create a gradient every 5 milliseconds. And at the bottom you see the interval it achieves in doing so. So what it does, it writes the width and the height and then the amount of pixels that I need multiplied by 4 because there is an alpha there, and it just moves it with every calculation. And you see this runs very smoothly. 5 milliseconds, I have a new image. It's too fast, you don't see how fast it goes. It's just showing you that this can handle this kind of traffic between the application and the memory. But I have the same code in Java 11 where we use, to the bottom, where we have an object and an array. So we're talking to Java objects. So we are adding these objects the whole time to the Java stack, and they are checked if they need to be cleaned up. So they're living somewhere in the Java space and not in the memory space. And if I execute this same application, by the way, I'm using JBang. Who knows JBang? It's the best thing after the changes they have done with Java that you can just run a single Java file. With JBang, you can actually define, I want to run this with Java 11 specifically, and I can import some libraries. We will use that later in the next demos. But if I call this, and I've done several attempts to improve this code, but I always end up with the same result, is that this gets generated every 50 to 60 milliseconds. You still don't see the difference, it still goes too fast. But it just shows you that removing the overhead of storing data in Java objects instead and moving it to directly accessing a memory segment, that we can speed up a lot of things. And that was one of the goals of the FFM API, to be able to put things in memory, read them back, and maybe exchange them with other applications. That's where we come to in the next one. For the native calls, I have 3 demos. I will show you the simplest one. So what I need to do to be able to call an external library, I need a linker. So that's the JEP which was in between, to be able to link to a library. I have a lookup, where can I find it? And then I have, for instance, the string length. So what we are doing here is we find the address of a library which can do string length. Of course, we can do this with Java, I know. String has a value to get a length, but we're going to do it now the native way. And then I know that my native library returns me a Java long, a long value, and it needs an address of the string value in memory. And that's the next thing we're going to do, is actually define a memory segment, put into memory a string, and then call invoke the library, telling it you find the string in memory there, and give me back the linked. So instead of this whole complicated flow of needing to define JNI and JNA objects and Java objects and C-compiled headers, we can just directly do this pure in Java code, making it much more easy to read and to execute. So if I run this, by the way, yeah, let me do it this way. Then we get that this was 14. I know it's not the right way to get the length of a string in Java, but it's just an example of how easy it is to call a C library to do this for us. One warning here: the unsafe in the past meant you're doing something dangerous. You're touching the memory outside of what is being managed by Java, so you can actually do bad things if you don't know what you're doing. So at this moment, if you're using the FFM API and asking something from the memory, you get this warning. So it could be that it doesn't work in the future if you not add this flag enable native access. So we're not sure yet. I think at this moment they don't know yet what they want to do with it, but it's a way to warn people, don't mess up the memory, because you can do really bad things or even dangerous things. And then there are 2 more demos in this demo application which also access native calls. Now, let's arrive at the Py4J and what happened there. So I showed this before. So you have this black box in the middle. How do we talk to the GPIOs of the Raspberry Pi? The Py4J itself also evolved a lot. There was really a breaking change between 1 and 2, the first red line. And now we are preparing to release a version 4, which will be based on Java 25, bumping from 21, meaning we can use the FFM API and we are on the latest LTS. The architecture of the Py4J library is pretty complex. It's a pretty complex project, but the important part here is the big black line in the middle. The architecture of the library is as such that you can plug in a provider which is able to talk to the GPIOs, and we have several of those in the past. So the new one, which enables the FFM use, is where in the black part there it's being injected, so that it can handle digital inputs, SPI, I2C, all these ways of communicating to projects. If we go to the Py4J project, it's a multi-module Maven project. Here you see the plugins. You see we have several plugins because we needed an extra one for Raspberry Pi. We'll come back to that. But what you see is that each of these plugins has a library, and that's where the complex code is. This is the code I don't understand at all. I've never touched it. I don't dare to touch it. But that's where you have things like this. First, we need a Docker build, which converts some libraries to a format that they can be used on the Raspberry Pi and that the GNI headers are created. Then this kind of wizard book of calls is how you call actually the native library. Yeah, it probably makes sense, but not to me. So this complex code here, and that's actually, you see here we have now an FFM plugin, but we don't have this library anymore. So we are removing a lot of complexity within this project. Again, this is fully open source. Please take a look if you're interested in how and we're doing things there. Raspberry Pi history. One important story here is we had a very good compatibility with all types of Raspberry Pis until 2 years ago, September 2023, with the Raspberry Pi 5. What they actually did on this Raspberry Pi 5, because they were having too much evolutions in the SoCs, in the chip they were using, is that they added an extra chip which actually does the communication with these pins, and this completely broke with the previous flows, so our Py4J library didn't work anymore. And that's the fun thing, is that then someone from the community stands up and says, yeah, I think I can solve this. And he did it. So he's a student, he needed this for his thesis project, and he implemented it himself and contributed it back. So a young guy one day popped up in my mail, I have a solution for you, do you want it? Yeah, of course. And he contributed to the project. And that's a new implementation that he added, so this black box in between such a plugin to be able to talk to the Raspberry Pi 5. So if you look in the documentation website, you will see that there are different providers. Some work on the Raspberry Pi, some need sudo, so they're all having some difficulties. But it seems that with the FFM approach, we will be able to remove all of these and make it a lot easier for people to start experimenting. And the same thing happened again with the FFM API. We were thinking about, since Java 22, oh, this would be really great if we could do this. And while surfing the web, like we tend to do when we should be working, I found this project by Digital Smile, Nick, which actually is a Java 22 plus library for interacting with GPIO and hardware interfaces. So he solved it. He had something working. And we asked if we could use it, and he said, no, I'm going to contribute it. So he's now part of the team. He made a pull request with 157 files changed, so it was pretty major change. But as you can see, it's merged. So that means that our snapshot built now, 4.00 snapshot of Py4J, is fully based or integrates with the FFM approach. So you can already start using it. So as I shown you here, so here is the plugin. And actually, I'm a good Java developer, so I can understand this. Sometimes it's pretty technical, again, because dealing with hardware is about very strict timings and very small data packets. It's about bits and bytes, not some strings or JSONs, so it can be pretty difficult to interact with these kind of components. But if you're really into this topic, you can go into here and find out that it's really readable. Huh? The context, it's still a bit cryptic because you have this method handle, but it's the native linker. So it's readable again. These are all Java methods and Java objects. So it's readable, it's understandable, and it's a lot easier to maintain. And that was the goal of the FFM API, to remove that complex JNI approach. So if you look into the source code of Py4j, you really see the difference. So instead of the upper is an existing plugin where you have 5 levels of code before we actually execute something on a GPIO. While with the FFM API, we just go directly from Java code to the kernel. So we can have a direct access, which is a lot faster. If you look at the benchmarks, the upper one, the current one has 0.1 milliseconds to get the state of an input, while with the approach we had, it takes 10 milliseconds. Still very small, but the differences are very large. Linux FS is another way of doing it, but that actually touches the hard disk and the file, so that takes a lot more time. When we use SPI, which is another way of communicating with devices, the difference is not that big, but still it's more efficient. So the FFM API wanted to have at least the same performance speed as JNI, and we definitely think they succeeded in doing that. Open source project Py4j. So a few weeks ago, 2 people at the same time asked the same question: can we improve the project with driver support? So that means that there will be an extra repository to make it easier to talk to LCDs, to displays, to LED strips, to sensors, to I/O expanders. So they are working. This is a view of my mailbox a few days ago, just before this talk. I watched my mail and there were again 20 mails about pull requests and changes. So we will have soon this version 4 with FFM of Py4j. We will have support for more electronic devices with the drivers library. And we think even that we can expand further than just Raspberry Pi, because this FFM implementation of Py4j is based on methods which are available in Debian and the Linux itself. So that's also available for Orange Pi. There is Debian available for RISC-V processors. So why not start experimenting with those types of hardware boards? So that's something we're really looking forward to. Can we experiment with Py4j, interact with electronic components on these new hardware boards? Now, if we want to build something, I brought my CrowPi with me. So CrowPi is a little box with a Raspberry Pi and a bunch of pre-wired components. A fun thing is you cannot incorrectly wire something because it's already wired if you're using the built-in components. So it's really in the code that you have to check out if you miss something. And I always make the same joke: I don't dare to take this with me on the plane in hand luggage. It looks like a bomb thing. By the way, I got the CrowPi. This is version 1 and 2. I got the 3 for free. It's a Chinese manufacturer. They send it for free, and it's held at customs already for 2 weeks because they don't believe it's for free. So I have some code for you. There is a project on the Py4j website which fully explains how you can use that, also where you can buy them, but I don't get any profit for that. But we have, again, a student project on the Py4j website which has implementations in Java for all the sensors and components which are on there. So if you want to use the buzzer, the LCD display, you can start from that existing code. I added one extra component now, and that's the RGB LED. You see it, yeah? Looks very big on that screen. An RGB LED, because a blinking LED is the basis of every demonstration if it's about electronic components. So let's go into the sources. And that's where I will be using JBang. So what you see here is a JBang script. So it's a Java file which has this extra line on top to instruct JBang to handle this as a JavaScript file. I'm using snapshot versions of the Py4j library, so they are not officially released yet, but they are on the Maven snapshot repository. So that's why I always also have to add this repo here. As soon as it gets released, I can simplify this. And this is the basic code to blink a LED. So I have this RGB LED, meaning 3 LEDs are inside there, a red, green, and a blue. Each are connected to a wire, each are connected to a pin. I create them as a digital output. I put them low, I let them blink. And the fun thing is, I made a video of this, put this on my LinkedIn on Monday, and someone said, if it's a hello world of electronics, it should actually blink hello world in Morse. So I said, yeah, no problem, we can add that, but you have to do a pull request. So he did. And he lost his GitHub account, because in the pull request he added these links on how he created it, and GitHub thought it was some kind of dangerous attack. Luckily, he got it back after an hour. So Jonathan Stronghorst, he's here at Devox. I don't think in the talk he had something else, but he contributed a change here in the application. So this is the screen of my Raspberry Pi. You can run Visual Studio Code on Raspberry Pis. You can install all the Java tools. You can install extensions for Visual Studio Code to do that. And you can directly run a JBang file like this just by clicking it on the sources. And now we should have something blinking. Yeah. Can the cameraman zoom? Thank you. Or did it already? This is the Morse hello world. Can someone read Morse code? I didn't unit test it, so I'm not sure. I have another example. So you have here in the middle, you have this distance sensor. This works the same way as a bat flies. So you have this reflection of sound. So if I start this example, it has an input and an output. It tells the sensor I want to measure the distance, and then the output is in a high state for the length of the duration that the sound is traveling. So the ceiling here is 801 centimeters above the table. And if I put my hand here, then you see that the distance is changing. No rocket science, but this is using FFM API. So this is using the newest version of Java and the new way of how we can interact with these GPIOs. Thank you for joining, and if you have any questions, please come see me. I'm also at a Zool booth in the afternoon. Thank you.